Welcome to a short video describing the Regional Resilience Determination Tool, or R2D tool, developed at the NERI Sim Center. The NERI Sim Center provides next-generation computational modeling and software simulation tools for the natural hazards engineering research community. R2D leverages the capabilities of several tools developed over many years at the Sim Center, enabling them to be employed in a regional analysis workflow. R2D is a combined simulation and geospatial processing tool geared towards assessing the impacts of natural hazards on urban regions. The integrated workflow allows for the prediction of regional scale damage and recovery at a building level and household level scale. Let's take a look at some features of R2D, including various analysis inputs, such as building datasets and hazards, and what outputs are available and post-processing options. Currently, R2D supports the analysis of buildings subjected to earthquake ground shaking and hurricane wind and water hazards. Soon, R2D will support lifeline analysis, including gas pipelines, roadways, and electrical transmission systems. The benefits of adopting R2D over other natural hazard engineering tools is that it is open source and free of charge. It can leverage high-performance computing resources at design safe, enabling large-scale regional analyses at the click of a button. It provides support for high-resolution assessments at the building level, offering remarkable granularity in the inputs and results. And it allows researchers to incorporate their own damage and loss functions into the analysis workflow. Currently, R2D supports the import of building assets in a tabular CSV format and in several common GIS data formats, for example shapefile or geodatabase. Researchers can get started by running one of many examples that come pre-packaged in R2D. Each example illustrates different building and hazard inputs, while highlighting the various modeling and analysis options available in the workflow. Researchers can also take advantage of rich datasets available for several regional testbeds, including Lake Charles, Anchorage, Atlantic County, and the Bay Area. R2D has built-in functionality to estimate hazard intensity measures easily and quickly across a region via hazard simulation workflows for earthquakes and hurricanes. Researchers can select a grid on a GIS map, input values for predefined hazard parameters, and generate spatially correlated grids of earthquake ground motion time histories, intensity measures, and hurricane wind fields. Large-scale regional analyses employing hundreds of thousands of assets can be run in parallel on high-performance computing resources. R2D is set up to assemble the inputs and deploy the analysis remotely to the design-safe supercomputer. Researchers can also perform small-scale analyses of a subset of buildings locally on their computer. Several convenient methods for asset selection are available. Researchers can select assets through the GIS pane and through advanced filtering expressions. R2D utilizes the Pelican Damage and Loss Framework, developed at the Sim Center, for estimating losses from earthquake and hurricane hazards. Depending on the type of analysis, simulations provide repair costs, repair time, and injury estimates. Uncertainty quantification is an important part of R2D. Outputs are estimated through statistical sampling. Besides the individual samples, summary statistics like the mean, standard deviation, and percentiles are also provided for each building. R2D incorporates the QGIS geospatial visualization engine and its core functionality. Researchers have the option to change the base map, add their own layers, perform calculations to create new data in a layer, change how assets are visualized and rendered, and create report-ready visualizations without ever leaving R2D. Results can be filtered based on complex expressions, and R2D also provides the option to export the results into many common GIS formats for sharing or for reuse in R2D in later analysis and results processing. The versatility offered in post-processing of results allows for the comparison of different decision policies. For example, retrofit strategies, or highlighting buildings with high losses or prolonged repair times. Thank you for watching this demonstration of R2D. If you would like to know more about R2D or other SimCenter tools, please visit the SimCenter website at simcenter.designsafe-ci.org.